Ready?
Right. Well, welcome everybody to the 20th annual Brattleboro Literary Festival. This is our 20th anniversary. Had to make some changes, but here we are, and we have been here every year. I'm Steve Budd. I'm a festival volunteer. We're excited today to present Joe Mazur, who is a prolific author and most recently of The Clock Mirage, Our Myth of Measured Time. Now, before I tell you a little bit about Joe, you can submit questions via the Q&A button, okay, on your screen. If your question has already been submitted, you can upvote it to raise the priority a little bit so we get to it maybe a little faster, but you can do that. There will also be links in the chat to purchase Joe's book, as well as to donate to the festival. And a special thank you, of course, is there for our sponsors. So Joe is Professor Emeritus of Mathematics at Marlborough College in Marlborough, Vermont. His works have appeared in Nature, the New York Times, The Guardian, the Wall Street Journal, Slate, Science, and many other publications. He's been profiled in media venues like NPR and PRI. He's been on The Hidden Brain and PRI's Innovation Lab. He is the author of, and there's quite a few of them here, so I'm going to read you a few. One, Euclid in the Rainforest, Discovering Universal Truth in Mathematics. The Motion Paradox, the 2,500-year-old puzzle behind all the mysteries of time and space. Time is a pretty important thing for Joe. Also, A Short History of Mathematical Notation and Its Hidden Powers, and Fluke, The Math and Myth of Coincidence. In 2009, Joe was elected to the Vermont Academy of Arts and Sciences. In The Clock Mirage, Joe suggests that time interacts with each of our lives from multiple perspectives, including what physics describes about time, what psychology describes about time, and what biology and our own inner clock dictates to us about time. And Joe addresses these by bringing them together and addressing the intersectionality of all of these things. So I'm going to disappear, but take it away, Joe.
Well, thank you. Thank you, Stephen, for such a nice introduction. So let me tell you how my interest really began. For 30 years, I taught subjects that in one way or another involved the notion of time. And as Stephen just said, many of my books involve those notions. But I taught calculus, I taught special relativity, general relativity, and all sorts of courses having to do with time. But then one day, just one day, about 10 years into my teaching at Marlborough College, I had an astonishment. That day, I was co-teaching a science seminar. Now, these science seminars were really designed for students to just pick any kind of a journal article that they thought might interest them, but serious science journal articles in almost any field, as long as it was science. And they would come prepared to discuss the article, and they would come to tell us what the article was really about. Now, that's a pretty hard thing to do for an undergraduate, but they did it. So that one remarkable day, there was a young woman who was giving her speech to us, and she said, and she used the word time many times. And I interrupted her and I said, "Tell me, what do you mean by time?" And she said, "Time. Time is time. What do you mean?" And of course, you know, my astonishment was that that was my embarrassment, because I didn't know the answer to that. And, you know, I excused myself and I said, "You know, I'm sorry, but it's very strange for me to think of this at this moment, because I've been teaching about time for a good deal of 10 years. I studied time, but it never occurred to me that there is a question about what time really is. So this went on for many years, and the reason for this is that time is really an abstraction. So, like all abstractions, time comes from concrete notions. We learn them from the concrete and bring them into our vocabulary. This is a wonderful thing about abstractions. We bundle each from concrete specifics into representative terms, and we carry them along and put them into our language. So, for example, number is a good example. What do we mean by number? Well, we need 3, we need 4, we need 20, we need 100. But these are the number itself is an abstraction. The square is an abstraction. So mathematics deals with abstractions. And when they deal with abstractions, they're dealing with wonderful things that could be brought down to their specifics at some stage when we want to apply whatever we're talking about. Otherwise, we're talking about something that's so general it might really be a nonsense, but it might work as a abstraction. So the astonishment that I understood at that moment when I asked the question of this young woman, I had never before considered the question, and I asked others who might know something about what time really is. I asked Gerald Whitrow, who is a British mathematician who wrote many books about time, and I never got a really good answer from him. He gave me good advice, but I never really got a good answer from him. And then, let's say fast forward when I was doing the research about time, I asked astronauts on the International Space Station, long-haul truck drivers, horologists, none, except for the prisoners prisoners in solitary confinement or had been in solitary confinement, except for them, they said they had never asked the question. And that was a very strange thing for me to think that a horologist who deals with time all the time couldn't express what time was really about. So let me read a little bit about what this horologist actually says. I will read a little bit. So I asked him how he thinks of time itself and what he thinks time might be. For me, he said, time is very concrete. As I'm working on a clock, I punch in the starting time on the timesheet. I punch a clock that stamps the time. So time for me is a measurement of activity. The clocks themselves can measure time in precise enough, the clocks themselves can measure time in precise enough seconds for any reasonable human activity. He points to the clock on his workshop and tells me that any one of them can count seconds accurately. Then, after pausing for a moment of quite quiet thought, he says, funny, I've been at this craft for over 20 years and never consciously, truly asked myself the question. I'm on the business letterhead and listed as a horologist, loosely translated, one who studies time and the making of timepieces. What I do here is restore these beautiful antique mechanisms in order that they might yet again provide the timekeeping qualities the original makers intended. We reanimate these handcrafted pieces, and for a moment, just a moment, we become one with the original maker of the clock. It was not the answer I was hoping for. Rather, It was an openly spontaneous one coming from someone who spends so much of the time working on mechanical clocks that he feels at one with their makers, a time traveling moment. Other clockmakers give similar answers. Whatever time may be in the abstract is not important. For the clockmaker, it's the measurement of time that is essential. It's the mechanics of time's movement forward that has ultimate value. All we need to know is the start and finish of a period of activity. One of the deepest insights of what time is comes from the art of knowing that time is passing. The interval of time spent and the remaining interval of time before the activity ends. The clockmaker knows that, and knows that all attempts to nail down any deeper notions end in an illusion positioned in a phenomenological quagmire. So that is what we have for the clockmaker. Now, why is it that, that these people who really deal in time in one way or another, like myself and the clockmaker and people living on the International Space Station for a whole year, don't think about what really time really is? They just see it as something. Well, the problem really is that time is multiple things. It's something to one thing, it's something else to somebody else. And the problem is that we know something is passing, but we don't know really what that is. It's we have too many kinds of time. We have psychological time, we have physical time, we have relative time, we have objective time, we have subjective time, we have cosmic true time, we have universal time, absolute time, quantum time. And then we have human time. And that's what I wanted to concentrate on, the human time. And the reason is that the physicists have their books. They've been having their books for at least a century since relativity came about in the early 20th century. But the physicists have commandeered popular books on the subject of time ever since Stephen Hawking's A Brief History of Time came out in, I think, 1988. And ever since then, it seems like time is physics time. And so my concern is to consider other things, that is personal time. Personal time is really essentially what we feel and what we understand as time in our bodies. In the last 20 to 30 years, chronobiology has made remarkable advances. We now have information about health in relation to circadian rhythms. There are hundreds of journal papers on time, time physiology, along with body clocks, regulation of sleep, metabolism, and the immune system. Where are the popular books that bring out the chronobiology excitement? Now, for the last 20 or 30 years, all of this has been happening, and it's quite exciting. The excitement, well, let me tell you, there is a great deal of excitement. And that's what this book is really trying to be about. Let me then read a little bit more about that. We have all sorts of time: Kantian time, psychological time, physical time, mathematical time, relative time, and I just read some of those essentially to you. These attempts to answer the big question of time strangely reinforce, complicate, and resist each other. None give a persuasive answer, yet together they offer a dialectic with no obvious resolution. The big question seems to bring us to a rather fertile, endless maze built from a family of answers full of differences and likenesses, joined by the now in relation to the past and future. All of those times are interrelated with traces and shades of interminable ambiguities that defy strict unity. They battle each other. They buttress each other. They complicate each other as they all stem from that single word with multiple meanings in discussion with one another. They are a pack of disparate accounts, seemingly without any integrated interpretation or resolution, and without a unified theory. There should be more than just one word for what we mean by time. However, the times we really care about are simply the ones connected to our human senses. For those, we have a unified theory built on attention, memory, and perhaps a cellular zeitgeist. We know that kind of time. We know what it is. For thousands of years, we've been asking the wrong question, searching for some noun that we can envision or conceive, like weight or power. However, understanding what something is often defined by what it does. So perhaps we should be looking for the verb rather than the noun. A saw is generally a thin, flat blade of tempered steel with a line of triangular teeth mounted to a handle. That is the object. But the object itself is pointless without some indication of what it is used for. Perhaps we should think of time as the being that moves us, the thing that keeps us going, the thing that makes us feel alive, the recording of life. The clock is the measure of that time. But in the mind, that clock is just a mirage that we follow for a sense of achievement, as if it is real. Perhaps that is why time seems to accelerate as we age. We might just be trying to catch up with that mirage before it's too late. So that's a piece that tells us a little bit about the numbers of the different kinds of time and the relationships that they have. And what I've been really trying to be concerned about is the popularization of what we mean by personal time. And so with that, we have something that we generally know about a little bit. We know we have a body clock. The surprise there, of course, is that we didn't know that in 1972, for example. It's a great year, by the way, 1972. That's the year my first daughter was born. So I cherish that particular year very well. But there is something else. There is a kind of hallelujah to understanding the body and how the circadian rhythms really work within the body. So my book distinguishes personal time from all others by bringing in what chronobiologists and 21st century explorers, I would call them the Magellans of the brain. You know, every year you hear a new piece of the brain that you've never heard of before. They discover these things like old Magellans and you know, sailing across the brain to find new pieces that really matter. And so what did they find? They found a group of 20 to 40,000 neurons somewhere in the hippocampus, and it happens to be called the suprachiasmatic nucleus. Now, what does that mean? That means the suprachi just means, the supra means above, and the chi is the old Greek letter that looks like an X. And so there's a kind of a similarity with an X, what's going on there. And it's curious, this suprachiasmatic nucleus, that if you look at it and you see just above it, you see about, I would say 40,000 neurons. And you see a number of, we got some wind coming in here. You see a crisscrossing of the nerves that are coming from the synapses coming from the eye. So you have the left eye and the right eye, and somehow half of them cross over and they go way into the back of the brain. They go to the occipital lobe in the back of the brain. So there's a little transformation that goes from the front of the brain, or somewhat in the middle of the brain, actually from the front of the brain, because they're coming from the eyes, and they cross over right at that point. And there's a really interesting reason for this. Of course, there's no real reason, because it was evolutionarily done by some kind of stochastic process that was really just random, but it just happened to cross at a certain point, and that is exactly where the suprachiasmatic nucleus is. That suprachiasmatic nucleus is very interesting because it is kind of a master clock in some sense, but it's also a regulator. It's a governor. It makes sure that whatever's going on in the liver, let's say, in the heart, and the intestines, and everything else, all those cells are being synchronized for their times, what they are doing. So in all the cells in these organs of the body, we have little clock genes. They are actually clock genes. These were discovered just for somebody my age, when you talk about 20, 30 years ago, it seems like a long time ago for young people, but it's just around the corner for me. So only 20 or 30 years ago, these clock genes were really isolated and not so much discovered, but identified. So at this point, you have clock genes in the cells, and what they're doing is they're turning on and off some functions. For example, the production of proteins. Proteins are, well, there's the nucleus of the cell, and then the cytoplasm of the cell, and then the ribosomes. The ribosomes are really just, well, it's a laboratory for making proteins, and they needed instructions. So the clock genes are giving instructions. They're messenger RNAs. They're giving instructions to the ribosomes to produce proteins. Some of those proteins are stable, some are not. And they produce, when do they produce the proteins? At night. It happens pretty much only at night. And proteins are produced. You get too many of them. Some of them migrate back into the nucleus, and they disappear. Some of them are active. They do what they're supposed to do. They keep us healthy, keep the immune system working, build new cells, repair old cells. They do all this stuff. But in the daytime, the inactive ones, they just disappear. They just disintegrate. They disintegrate until nighttime, and then the whole process starts over again. So there's a kind of a rhythm of activity that's going on. But how do these cells know anything? They're not seeing any, it's all darkness. I mean, there's nothing, there's no light in the body, right? How do they know this? Well, they're getting cues from certain things that are the voltages that are getting higher and lower, that are coming through the X of all of the synapses that are going through this suprachiasmatic nucleus. And that is a regulator. It's a regulator to say, I'm gonna, if any of those cells are off register with their timing, and they're told, they're sending signals. So there's a kind of a synchronization of what's going on. Now, this is really quite surprising and quite amazing. I find, this is really striking to me, that my body is filled with these little clocks. So, how does the suprachiasmatic nucleus actually do this? Because what do we call a clock? I mean, a clock has got, any clock has to count something. If you think of any clock you want to think of, it doesn't matter what it is, a water clock, a sand clock, even a sundial, every clock has to count. That's how we know what things are. So how is this suprachiasmatic nucleus counting? It's counting the waves of voltages going up and down and up and down and up and down. So it is a clock in a sense, and it's got accuracy from essentially the eyes. Now, you might ask a question about, well, you know, blind people have to also have circadian rhythms in their bodies too. So that's a different question, but it's not only through eyes that you get that circadian rhythms, you get it through all sorts of things. And you can get it through hearing as well. So that's the feedback. The feedback is you've got this suprachiasmatic nucleus, which is the master clock, making sure everything is going well. And then you have all the cells doing all their work down below in all of these organs. So let me, I want to read one interesting little piece. If I have some time to do that, I think I do. I want to read at this point. Yeah. Here's my next reading. We could think of time in the way my granddaughter, Lena, taught me to think of it. For many Thursdays, I would meet her after school for a chat at a local cafe. On one of those Thursdays, when she was 11 years old and in grade 6 studying the cell, I asked her if she knew about genes and proteins. Of course, she said. They, the proteins that is, are made during the day or night, I forget which, but they know what time is. What do you mean? I asked. How does a cell know anything about the time of day? Your whole body knows, she said assuredly. Every cell knows the time, like as if all they have to do is look at a clock on the wall of the brain. That's how we know when it's time to eat, like, I'm hungry now. Can I have another chocolate croissant? We know that the clock is with us. And within us, in every little thing, in every little living thing. We know that cell clocks in almost all living things are calibrated to the circadian rhythms and are not bothered by relativity. That rhythm is not an illusion. It is real. And unlike St. Augustine's answer to his own question, we know what it is. Most of us, almost all of us, know that. And we know that circadian rhythms are persistent, are what consistently keep us tuned and alive. I say, let the physicists and philosophers have their coinciding ideas about what time is, so they can explore the mysterious dynamics of subatomic particles and the unfathomable reaches of the universe, the deeper existential questions to understand where we came from and where we're going along. For us, though, the answer is much simpler. It is the inner feeling that rides on the rhythms of our cells. We can feel it through our bones with relaxed acuteness that is good enough for normal life. When now and then we need a sharper sense of time, we look at a clock. Lena could be right. We didn't look further for an answer to the celebrated question. No, look no further. Time is us. We are the clock. So, I think I could go on, but it might be a good time to go to questions, if that's okay, or I could go on, whatever you think, Stephen.
Oh, Joe, I think you can begin to take questions. I notice you have a couple down there in the question box. You see them?
Hold on, let me get to them. I'm on a
Okay, it's under the
Is that
Q&A, and if you don't see it, I'll read them to you.
no. I'm going to have to read them aloud to other people. So let me
Okay,
just
all right.
see a little in the. Are we in the chat?
No,
No.
we're in the Q&A.
Oh, I see the Q&A. Okay. All right. Okay. So I have a question from my very good friend who is in England right now, William Cullen Brown. Thank you, William. He says, so an horologist is not actually someone who studies them. They are someone who fixes clocks. So what could be a good word for someone who does actually study time itself? Well, thank you, William. I think philosophers have been doing this since Aristotle. And, Plato had a very good understanding of time in his Timaeus, where he said, look, time is what the heavens tell us it is, and it's what the sun and the moon tell us and the stars tell us. The philosophers have been doing this for 2,000 years, so I would just call them philosophers. But those are people who are studying really the abstraction of time, and not what I'm thinking of as the time that is personal, the time that really passes us. Time is really about change. Let's see. So I have another question here. What about people who live up in the Arctic, where it is daylight and nighttime for weeks at a time? Very good question. They've been studied for circadian rhythms, and their circadian rhythms really hold pretty well. In fact, in a certain sense, it takes them a long time to. If you are somebody who is going to the Arctic, it's going to take a long time to adjust to that kind of living. But with the adjustments, somehow the body is so pliable and the brain is so pliable, it really will work after a while. You can really adjust to any of these things. As you know, that jet lag, for example, is a real problem for most of us anyhow. And it takes an awful lot of time to actually get adjusted. The body doesn't like it. It just really is very hard for it to actually get back to what it really wants to be. What about people in solitary confinement? I have another question here. People in solitary confinement, I've interviewed several people who had been in solitary confinement for months. Here's the problem with solitary confinement. It's not so much the confinement, it's the not knowing when your confinement is over. So you're not told when you go into solitary confinement, you're not told when you're going to get out. For most people, for the people, at least the ones that I've interviewed. So if you're there for just a few weeks or a month, and you don't know when it's going to end, that's really quite traumatic. And you do adapt to the surrounding by very strange, you do strange things. For example, one person told me that there are rats in these, in these terrible basement solitary confinement cells. They're really, it's rat infested. And he said, the first thing you do is you take off your socks, whatever you're wearing, and you stuff the holes, and so the rats don't come in. And then after a few days, you start to really begin to miss the rats. And you take the socks away, and you start to let the rats in, because they're your companions. You're actually communicating with them, and you start talking to the rats. So the real problem with anything like that is duration. And I've studied duration in many ways. For example, what are we in now? I thought that somebody, whenever I give this little talk here. I'm always asked about, what about COVID? You know, we're in this COVID time, and we don't know when it's going to really end. I mean, we had, certainly last year, we went through a period when we just didn't know when it was going to end. It's a duration that's endless because you don't know when it's going to end, and that is tough. Now, I didn't write anything about COVID because this book came out in April of 2020. So the book was already at the printers by the end of 2019. But ever since, I've actually read lots and lots and lots of papers about duration. And the whole question of duration is when you don't know when something's going to end, that's trauma. That can lead to a great deal of trauma. And so you can't imagine what it would be like to be in solitary confinement. I mean, you just lose your mind after a month. And I didn't interview anybody who was in there for more than a month, but there are people there, and there still is. There are people who are in solitary confinement for years. And the only thing they get is food, maybe a little exercise if they're lucky on their own. And that's it. I mean, this is really a terrible thing, inhuman thing to do, even for a month. So Stephen, is there anything else that we should be talking about?
Okay, I'm back, Joe. You know, building on what you just talked about, let me ask you to just say a little bit more about, you wrote about a person who went into a mine and stayed in a mine for a length of time. And of course, that cut out all of the signals, right? There was no daytime. So you lose everything. And how quickly, I was stunned, how quickly you begin to change, even your sleep cycles. I don't know if there's any more to say about that, but that was a fascinating piece.
Yes. So the question from my audience, by the way, everybody should know that I have an audience beyond my computer here. So,
very good. Very good.
So, so I'm going to repeat the question. The question is, these studies that were done when people went into mines that were totally darkened, these were circadian rhythm studies to test whether people could adapt to this and what their time responses would be in terms of the way their bodies would work and their senses of time. So these were done in the 1970s. Many of them started in the 1970s, and there are one or two that go way much further back, but they weren't significantly scientific studies. It's a difficult study to do scientifically because you have to communicate what's going on with somebody outside. So these later studies were done through electronic communications that were just done very, with third-party things and with people who were just slip messages back and forth. It was just a message kind of thing with paper messages. And what they found was that the circadian rhythms were fairly stable. You know, the rhythm would be a 24-hour cycle rhythm of the body, and they would feel it very well. But the people who were living in caves would think that, in fact, the time that had passed was slower or faster in some cases than the 24-hour rhythm. So it'd be, but it wasn't by much. That's the interesting thing. It wasn't by much. It might have been 22 hours or 23 hours, but it wasn't, it didn't go to, let's say, 10 hours or anything like that, which is surprising because in other tests where they tested people who had gone through traumas, for example, or through excitement, or any kind of strange kinds of adventures, they were also tested on how their time senses were moving, whether they were moving slower or faster. And it turns out that, there's a tremendous dilation of time sense for people who are frightened, in fright. When you're frightened, and I assume that goes back to primordial times when, the fright was a whole question of whether, the saber-toothed tiger is, just beyond the cave, and there you are. What do you do? And you have to have that moment of reflection as to whether you run or hide or what do you do. So there's like something going on there with your timing. And so these studies are really very interesting. That and they're in the book. Thank you for that, Stephen.
So, Joe, we've got a few minutes, and I got a big question.
I like
and,
the.
maybe you'll end up writing about this a little more in your next book. And just a caution, I'm going back to the physics because I've, the science world is, predominantly a lot of physics books coming out these days, Joe. But from the perspective of as a mathematician, when I read about physics and I read about equations that have time as a variable, and they tell me that it doesn't matter whether time is moving forward or backward.
Mm-hmm.
That's confounding to me.
Okay, so I'm going to repeat that question. I don't know whether the audience has really heard it, but Stephen is asking, in physics and mathematics too, there's the little t, the symbol t, which is supposed to be time, and in many fields, in fact, there's especially physics, there's the t is supposed to represent a number, and the number could be positive and it could be negative. So the question is, if in the physics the equation, you can actually make you can slide time from being positive to being negative, then why can't that be a real negative time? And the answer is you can. There's no stopping you from doing that. And that is, in other words, if you're going to think of it as cosmological time, then there's a whole question of where do you put the zero? In other words, the zero is the separation from the positive to the negative. So where do you put that zero? Well, the physicists would say, well, put it at the Big Bang. That is, the Big Bang has some kind of a future time, and they will say that that's when time begins. There's no time before it, but there is a negative time before that. So there is the question of the negativity of the Big Bang. But there's also a lot of physics that deals with a negative kind of time that gets us into a whole lot of different areas of what we mean by negativity.
Ponderous to me, Joe. That's wonderful. We're at 1:14. We got just a minute.
Give me one for, yeah.
I won't ask you another question. Well, I was actually like two main questions. The audience doesn't have any more. Anything else you'd like to tell us in the minutes you have, Joe?
In my audience here? What?
Whatever you'd like to say. Yeah, whatever you'd like to say. We got another minute or so.
Oh, okay. What I'd like to say? Well, I just think we have to get out of this notion that, whenever we think of time, we think of it as, as you say, we have so many of these physics books that really are somewhat misleading us into judging that time has to be relative, because it's a completely different idea of what we're talking about. We live on a particular planet. If we leave the planet and we want to speed up and go at some lightning speed and live somewhere else, we'll have a different kind of sense. In fact, we have a 24-hour system here, and we go around the sun once a year, and our bodies have adjusted to those things for millions of years. And the whole question of thinking that we have to generalized time to the point of dealing with relativity when we are simply living on this planet, it's a little bit stretching it. You know, in the book, I talk about a person who's on a merry-go-round and another person who's sitting watching the merry-go-round, and then talking about the differences in the ages, because one is moving and one is not, relative to relative to the person who is sitting and watching. So, but you see how that's interesting. It's extremely interesting that we can have this relative time, but it's misleading. It doesn't give us the real notion of what we really think of as time. We live in this planet.
Yeah. Golly, Joe, you know, I think that you're a wonderful popularizer of science, and that's so important today, you know, particularly in our time of poor science understanding. I'm not a scientist myself, Joe, but what I do is I work with faculty, helping them prepare their National Science Foundation grants. So as a non-scientist, I really appreciate you as a popularizer of science, and I could sit around and have coffee with you for hours, I think.
Thank you so much, Stephen. That's
I
great.
appreciate you being with us, Joe. Yeah. Well, it's 1:17. I guess we leave now.
That's okay with me.
Okay. Yeah. Well, you know,
I'm going to give a little plug for Kia Corthman. She's up at 2:30, and she's going to be here at this pod, and she'll do the same.
And that's right after Carl Zimmer, which I will be next.
Oh, and Carl Zimmer. Right. Exactly. Right.
Okay. Okay. Signing off, Joe.
Okay. Thank you so much.
Thank you so much.